To find the extrema, we do begin by taking the derivative, right? So, the derivative of this function, using the power rule, this is deja vu if you saw the other video. We set this derivative equal to 0, and we solve for those critical numbers. We've already factored this by grouping in the past. We can check to be sure that this is the correct factorization using FOIL. When we set these factors equal to 0, we solve, isolating x. We move 2 to one side. We subtract 2, add 2, divide by 3. So if you watched the first video on this unit about finding critical numbers, this is deja vu. We have critical numbers at x equals negative 2/3 and at x equals 2. Now our extrema are going to occur either at one of the end points, or, so it could be at negative 1, it could be at 3, could be at negative 2/3, could be at 2. We've got to investigate them all. So let's check out f of negative 1. We do plug these 4 values into the original function. Cube negative 1, negative 2 times the square of negative 1, negative 4 times negative 1, plus 8. This is negative 1. This double negative turns positive. However, there's another negative right there. So I got negative 2, double negative makes positive 4, positive 8. When we put all this together, we've got 9. So we'll hold on to that f of negative 1 is 9. We're looking for maximum and minimum points, but only on the interval, negative 1 to 3. Let's investigate another function value. Let's try the other endpoint. If we want to evaluate f of 3, we plug a 3 into the function. That's 3 cubed minus 2 times the square of 3 minus 4 times 3 plus 8. That's 27. Take away 2 times 9. Take away 18 minus 12 plus 8. Put all that together, we got 5. Let's hold on to that function value, that f of 3 is 5. We still have a couple more to investigate. When we do investigate f of negative 2/3, of course, we plug a negative 2/3 in everywhere we see an x. We can either play with the fraction or with the decimal. If we cube a negative, it stays negative. 2 cubed is 8, 3 cubed is 27. Let's see. If we square this negative, it does become positive. Positive 4/9. Positive 4/9 times 2 over 1. Well, that's going to end up being a positive times a negative. It'll give us negative 8/9. Next, I've got a double negative, and that 4 is the same as 4 over 1. If we multiply this out, we've got 8/3. And then I do have just 8. To combine these, if I'm still playing with the fractions, I need an LCD. And the LCD is going to be 27. So 9 times 3 is 27. 3 times 8 is going to be 24 over 27. Another version of 8/3, if I want to get that to 27ths, 9 times the 3, 9 times the 8. And if I want to get another common denominator here, this 8 is the same as 8 over 1. 1 times 27 is 27. 27 times 8 is 216. If I put all of this together in fraction form, I've got 256 divided by 27. So in conclusion, we have a point where f of negative 2/3 does meet 256 of, f of negative 2/3 is mapped with 256 27ths. We'll hold on to that. If you're not really thrilled about those fractions, rounding would be appropriate here. We're really thinking about where we have points on a graph. That's about negative 0.67. And 256 out of 27 is about 9.48. We have one more to investigate, and that is 2. If we plug a 2 in, 2 cubed minus 2 times the square of 2 minus 4 times 2. Okay, so we got 8, take away 8, take away 8, plus 8. That's a lot of 8s. In the end, we've got 0, telling us that f of 2 is 0. Okay, so recall. We found that f of negative 1 was 9. We found f of 3 was 5. We found f of negative 2/3, which is about this much, is equal to 256 over 27, which is about that much. And I realize now that considering the decimal is rather helpful, because we're looking for the highest or lowest y value. I see a low right here, and we've got a high right there. So in conclusion, let's write this as an ordered pair. We have a max where negative 0.67 meets 9.48, and I wrote that as an ordered pair. We have a min where 2 meets 0. The end of finding the extrema.